Okay, class, so we're going to get started, but first of all, I feel like I should give you some review before we get to like exactly what permutations and combinations are. Okay, so let's see if we can calculate what this is and then talk about the meaning of it. So 5 factorial is what that's called, and the way you'd compute it is you do 5 times 4 times 3 times 2 times 1. Okay, so that button is actually on your calculator as well. I'll show you that in a minute. Okay, so you could just do it kind of in any order. So this is going to be 6 times 4, 24, times 5, going to give us 120. Okay, all right, so that shows you how to do that. Now, what is a meaning for that problem? A meaning for that problem is you have 5 items and you're interested in the ways of, say, arranging those 5 items. Or maybe you have 5 students and you're interested in ranking those 5 students. Or it could be a problem of you have 5 students and you have 5 different jobs and you want to consider all the ways you could assign those 5 different jobs to those 5 different students. So those all would be meanings for 5 factorial in the real world. Okay, so one thing I should tell you at some point is what is the meaning of 0 factorial? And the meaning of 0 factorial is 1. And the way you could think about it is if you had no objects, there's really only one way to arrange them, which is not to arrange them at all. So that's just something, you know, even if you disagree with it, the way I explained it, it's just kind of what it is. You can type that in your calculator as well and kind of see that that comes out. But anyway, to get the math to work out correctly, that's kind of how that has to be. Okay, so let's work on simplifying factorials. So let's say that we have, for instance, 10 factorial over 8 factorial. There's a couple different ways you could do this, but I think it's just best to apply minimum effort, which would be to do something like 10 times 9, and hopefully this makes sense to you. Instead of just writing the numbers 8 on down, I could just write 8 factorial to represent the numbers 8 on down, and then over the 8 factorial. Of course, I could write the numbers 8 on down here and the numbers 8 on down here, but that's just a lot of writing, so hopefully you can see these shortcuts that I really could just write the 10 factorial like that, cancel those out, so it's just going to be 10 times 9, so it's just going to be 90, okay, which is hopefully that makes some sense there. Okay, so that's sort of the basics of working with factorials. Okay, so let's do some actual problems that are like permutations and combinations, that sort of thing. So let's go back to the problem of where you have to pick, you have 10 people and you have to pick a president, a vice president, and a secretary for that situation. You want to consider all the ways of doing that. Okay, so hopefully this makes sense to you. Like really, there's 10 choices maybe for the president, but of course once that's chosen, there's only 9 left for the vice president slot, and then for the secretary slot, there's only 8 left, okay. So it's just gonna be 10 times 9 times 8. Unfortunately, that's not too hard to calculate. So there'd be 720 ways of doing that. So if you understood the first topic, hopefully you would see that that's a permutation problem, okay? And so there's a special way that that's written, and that's written 10p3. Now on the quiz that I'm going to give you, which is only going to count as a homework, the subscript notation, I couldn't do that right, so it's going to look a little different, but hopefully that will all work out okay for you guys there. Okay, so let's go through what the definition of this is and how that works out with the actual definition. Okay, so the way, if I have n permute r, okay, the definition of that is going to be n factorial over n minus r factorial. Okay, so let's see how that works out for this problem, okay? So instead, I'm going to put 10 and 3 in, so it's going to be 10p3, okay? And then that's going to be 10 factorial, okay? And then I have to subtract those two, right, n minus r, so that's going to be 7 factorial, okay? And of course, using simplifying methods that I have before, 10 factorial, whoops, I need to write it, 10 times 9 times 8, and then times 7 factorial over 7 factorial. So what I do is I get the same 10 times 9 times 8, 10 times 9 times 8 that I had before out of this formula, okay? Because the factorials just kind of cancel out the right way. It all just kind of works out. So that's kind of how that kind of problem would work out. And then this is the formula. Go ahead and like write that down someplace special. They're in the book as well, but having them at your reference would be great. Okay, so let's contrast that with the next kind of problem, which is maybe a related combination problem, which is, let's say that you have 10 people in your class and you're interested in choosing 3 of them in order to make a committee. Okay, so let's think about that carefully. Okay, so it's 10C3. You're 10 people again. You want to choose 3 to make a committee, say for graduation or something like that. Okay, so you can treat it like a permutation problem at first. Like you'd say, well, there's 10 for the first slot, quote unquote, of the committee, and then 9 for the next one, and then 8 for the next one. The problem is, let's look at this more carefully. Okay, let's say you have Alex, Veronica, and Cassie on the committee. Okay, that would be the same selection as, Cassie, Veronica, and Alex, right? And believe it or not, there's how many ways are there to arrange 3 things? Well, we already studied that, right? So it's going to be 3 factorial ways to arrange those 3 letters. In fact, let's just enumerate them now. So we can have let's say A, V, C, okay? So we could have A, C, V. I could switch those last 2. C, V, A. And then I could have, let's see, so then I'd have VCA, and then let's put Alex in the middle this time. I have VAC and CAV. Okay, so the thing is, all of these sets, the point of that is they boil down to one set. Like, so in other words, everything's listed, like in the permutation set, everything's listed 6 more times than in sort of the combination set, if you think about it. So every listing would be done six times as many. So I don't want that, of course. Okay, so I can take the way I did the permutation problem and divide it by 3 factorial. Okay, so what's that going to give us? Remember, we calculated the numerator before, and that was 720, right? And then I can divide that by 6, so I'm going to get 120. Okay, so let's see how that works out with the formula. So the formula, running out of space here. Yeah, let's see if I can do it here real quick though. Okay, it's going to be n choose r. So it's n factorial over n minus r factorial times r factorial. And hopefully you realize, because there's that additional division in the combination problem, there's going to be fewer combinations for any associated problem, like if I'm comparing it to like a related permutation problem. Obviously, hopefully you see that's always going to be the case, unless you're picking one thing. Okay, so let's see how that works out. So I'm going to do 10C3. Okay, I'm interested from 10 things, selecting 3 where I don't care about the ordering. Okay, so it's going to be 10 factorial, okay, over... Now, n minus r is going to be 7 factorial, and then I'm going to have this additional 3 factorial. Okay, so how's that going to work out? Let's work out the numbers. It's 10 times 9 times 8 times 7 factorial for the top. Okay, and then I'm obviously going to have 7 factorial here, and then 3 factorial. Okay, so I'll cancel those out, and then I get 10 times 9 times 8 over 3 factorial. I've seen that before, so it does come out to be 120. Okay, so just to summarize the upshot of these things, the 10P3 gave us 720, right? And then the 10C3 gave us 120. Okay, so on your calculator, these buttons are, or these things are available. Okay. So what I can do is, well, depending on your calculator, it might work a little differently. I could probably show you on the other calculator, but basically they're in the math menu, and then you want to go over to probability, and then you'll see this. Okay, so NPR. So the way it is on this calculator is you can put things in the slot, but I think some of the older calculators, you have to just push a 10 first, and then the NPR sort of function button, and then the 3. Okay, so you're gonna have to play with your calculator. Let me know if you can't get it to work. Okay, so there I get my 720, and of course I could do 10, and then go back to math and go back to probability, and then I'll go down to NCR. That's gonna be here, okay, and then I'm gonna put in 3 for that one. Of course I get 120. So the formulas all work out as they should for that one, so hopefully that gives you some verification of how that all works. Okay, so let's actually do another one. Let me do the handshake problem. Okay, so let's say there's 10 people in a room and you want to consider all the handshakes that you could make, okay? So it's kind of weird. What you could think about it is this way. There's sort of 10 people that you could sort of pick for the first person in the handshake, and of course there's only 9 next, but of course I would want to consider a handshake between Alyssa and Veronica to be the same as Veronica and Alyssa, right? So if they're involved in the handshake, it's just counted as a single handshake. Okay, so what I'd have to do, everything would be, if I listed them all sort of individually like that, they'd be listed twice. So I have to divide by 2 factorial to account for the fact that, like, or just by 2 in this case, to account for the fact that, like, everything would be listed twice in that arrangement. Okay, so 10C2 would be how I'd imagine that answer. And again, how would it work out with the numbers? It would work out 10 factorial, okay, 8 factorial, 2 factorial, like that. Okay, and of course, you know, writing it all out is 10 times 9 times 8 factorial, 8 factorial, 2 factorial, boom, boom, and I just get 10 times 9 over 2, so 45 handshakes, and of course that one also works to 45 handshakes. So interestingly, what's cool about these problems is you could, oftentimes, like, the same problem solves many different situations. So if I have 10 points and I'm interested in how many, and let's say that no 3 of them are collinear. I need that one. 10 points, and I want to know how many lines I can make on that figure from those 10 points. That is also going to be 10 choose 2. If you think about it, 2 points are going to determine a line, and it doesn't matter, you know, which one comes first, that sort of thing. So that would solve that kind of problem. Okay, I'm going to pause for a minute. I'm going to present some other ideas in the next video.